Hello guys, and welcome to the second mini presentation of the lectures from subject Principles of Computer Graphics and Image Processing. This time we are going to talk about or work with bitmap operations and mostly line drawing. And we will be focusing on one algorithm specifically, and that is Bresenham line drawing algorithm. If you're looking for the Slovak version of this presentation, well, I would recommend you to go to the lecture site of our lecturer Martin Maduras, because this mini presentation is mostly just a translation of his video, and I'm also using his slides, and well, maybe it will be also a few enhancements to his presentation, but mostly it, because all you need about the algorithm is in the original lecture. So I'm going further. This is actually some sort of a recapitulation from the lecture, and I'm going to talk about what is line, how to draw it, and what is the error we are talking about while drawing it. So what is line? Well, in geometry we can define it as a straight one-dimensional figure that has no thickness and extends endlessly in both directions. Or it can be also defined as or described as the shortest distance between any 2 points. So line is actually endless. We are not talking about line actually. We are talking about a vector that has its beginning and its length, or actually the orientation. So in computer graphics we have line restricted with its beginning point and its ending point. And when we have line, we want to draw it, and as we are drawing it into pixels, we have to select which pixels should be colorized with our defined color. And also between the beginning point and the ending point. So we have the coordinate system, the beginning coordinates, the ending coordinates, and what is the first thing we can do? We can iterate over these pixels and to think where we can draw the pixel into. But we can go back to some math, and we can describe the line as a function. And on the coordinate epsilon, we can draw it with combining with the angle, sort of, and the bias. By this, we can define how to draw line and how to compute it, the pixels that it's covered by the line. So, if we want to draw a line, we just take the function and use x as the shifting point, or shifting the pixels, and we just draw it with plus bias on the first starting location. So we take x1 and compute the function to get the coordinate position epsilon, and we go from x1 to x2. See, we have for each pixel between these 2 points epsilon x and epsilon. What is the problem here? As you can see, some of these pixels, or the values, are not exact on which point it should be, or in which pixel it should be in the coordinate, because this is a problem with floating point, and this is a floating point error. And we have to correct this error and to select on which of these two pixels should be which of these 2 pixels should be colorized. And what can happen? Sure, if we have the angle very low, or it's smaller than 1, you can go back to analytical math and learn what it means. We can draw the line kind of perfectly in just 1/4 of a circle of the coordinate system. But if we get a problematic m that is much higher, or when we have the line where x coordinates are short and the epsilon coordinates are very far away, then we get these gaps between drawn points, even though they are very close to each other. I mean, iteratively each x has this point, the epsilon points doesn't have them. So yeah, if we're thinking about the basic code, like iterating through every point, every x, and draw the image, draw the pixel only to the epsilons we get, we are accumulating error, and the error is with that shifting point, or the shifting distance we want to add another pixel further, or to another coordinate. And if you look at it like here, when we are generating it now with our code, sure, we have the same or similar code here. When we are using very simple line, when we can draw each pixel next to each other, we see that the line is complete, but with a different shifts where the error is accumulated, we see that there are some gaps and that we can use it. Well, sure, we can use it this way, but you can't iterate over x. So what if we iterate over epsilon? Well, you can do that, sure, why not? But if you look at the resulting line, you can see that it's really not nice looking and not thin as it should be, or infinitely thin, or actually as it was said, that without a thickness. So we're trying to make it as thin as possible. We see that there are some duplicates that happen. And there are we getting to the Bresenham line, where we can see that these duplicates are, well, not actually eliminated or removed, but the error is not counting with them. So the thick one with the correct one. So as we've seen, the first error, the first code here, with very simple adding of the floating point shift, we can try to correct this equation with some simple mathematical operations, and we get to the point where in the function of drawing the line we have no floating point variables, which means that we have eliminated the error of moving to partial pixels, because now we are using only pixels where we have integer coordinates. However, well, and this is actually the part of the Bresenham line drawing algorithm. However, there is just one problem with it, and that is that this snippet of code works only if m, or the angle, is lower than 1, and it also works only if we are going from left to right in the coordinate system. If we had a different oriented vector, or the line, it would not work, because the subtraction x2 minus x1 would be the problematic, and the condition would evaluate as lower than the x. So, as I was talking about it, the coordinates in our template, or in our setting, in the template in our project, or the second task we are talking about, the coordinate system is actually a 2D array, as you can see in the code, and I will show you that. So we are talking about x going to the right and epsilon going down. and the center of coordinate system is at the left upper corner. So we know how the Bresenham line is drawn. We know that there is an arrow if you are using the floating point. We know that there is a possibility how to draw a line without using floating points. If you want to know the math, just you maybe Google it or look at it. Quite much harder than I was just jumping through it. And yeah, now you know how to draw a line correctly, and also how the coordinate system looks in our task. So what is the task? Is actually to implement the Bresenham function, the function with Bresenham algorithm to draw a line. Make sure that the function can draw a line correctly in all directions too, so not just the first snippet, and that it uses only integers. So don't just use the partial snippet or the first one, the floating points, get to the bottom of the algorithm, get to the end of it, and try to use it with only integers. And to be able to use the function to draw a line in any direction. And the specification of your assignment is in the Google Classroom. And it wouldn't be all without the snippet and the presentation of the snippet. Go to the task to Bresenham, open the CPP file, and here what we can see, there are a few includes, and we can see include vector, also include IOStream. Some of you maybe have used it in the last task, and also fstream. So what do we have here? We have unsigned integer for size that defines again the size of the image you are using, and by this it also defines the frame buffer called image. You can take a look at what the image actually is. We can see that it's a class with defined pixels, with some frame buffer and some functions that you can use it to set pixels or get pixels from certain locations, and to define the color of the pixels. There is prepared function drawLine that uses this frame buffer, and it asks for 2 points, first one from point and 2 point. So it's like in the algorithm. Point is defined very simply, it's just the x and y coordinate, as we are in 2D plane. So what your task is, define frame buffer and define vector with points. What it actually is, it's sort of a container with points, and the std vector, you can take a look what it is, find the definition, and as you see it's using template, because you can use this container to contain whatever type or classes, objects you want there. So this one is defined to contain points. So your task is to first define how many or which points you want to give there. So maybe points pushback. Let's say 0.00. That's it. First point is in here. Again, points pushback. Let's say point. I'm using the call point with the constructor. No, 10 by 10. So first we want to draw a line between these 2 points. Then we have to go through these points, iterate over them, and draw a line between these consecutive points. So this one should draw a very simple line from coordinate 0, 0 to 10, 10. If we add another line or another adding of these points to no, 30 and 10, it should draw consecutive polygon from 0 to 0, 0 to 10, 10 and a 30, 10. So there would be two lines. Well, actually, just like. And then you have here a function PPGSO image save VMP. It's a really simple function if in the library PPGSO that is saving your created image into task present.bmp, which you can view in whatever viewer, even here in Cilion. So that should be all. You can define your points like this or in some cycle, some algorithm to create it. Just be creative, and also here you have to write your function. That's it, and good luck.